Right. In this part of our course, like we are learning about the concepts, how we can store data, because I said when we begin this software engineering lesson, I said that software is not just set of instructions as you thought in your early childhood. So maybe you had idea when you start, like you had idea software is just set of instructions given to the computer to get something done, do something, but that is not actually. So it has more related components. So software is actually a set of instructions plus the related documentation plus data structures. Actually, within the software, we need to define a way of storing, retrieving, handling data. How can we manipulate data? How can we store data? How can we delete, update data? So how can we retrieve? How can we process data? And so all these things need to be defined within the software itself, right? So the system that we can use can be attached to the software, or can be so it can be like a flat file, a single file. So within the single file or single compiled code, you can include everything: data storage, data manipulation, so related data, everything can be stored in a single file. That's like a portable document. Or there are some other ways, multi-tier architectures. In these multi-tier architectures, you can store data in a separate place and your program in a separate place. So what do you think? Is it good to store these in two places, or is it good to store all in a single file? What's your perception on this?
I'd say on a single file.
On a single file, yeah, that is easy. Storing a single file is easy. But what happens in case of a software corruption? Data can also be corrupted, right? That risk is there. In case of a software infection, so let's say a virus attacked the particular software, or hacking, something went wrong somewhere, so that will definitely affect your data. For an example, think about your operating system. You said you were using Windows and you had to shift to Linux. If your data was with Windows, what will happen when you're switching into the Linux? You have to delete all the related data. Maybe if you have a collection of movies, tutorials, PDFs, books, and all, with the operating system, it will also be erased. Is it good?
Yeah.
Good or bad?
It's bad.
Yeah, it's not good, because along with the program code, you will lose your data as well. And another thing, so in case if you need to update, so let's say you are installing a new software. Let's say you are running with Windows 10 computer, and you need to install or update your operating systems to Windows 11. Do you need to lose data when updating to the Windows 11, or do you need to keep your personal data?
I need to keep my personal data.
Yeah, you need to keep your personal data while updating. You need the newest operating system, that is true. But still, you need your all data, right? So that is the thing, right? Therefore, not just that, the settings, maybe even if you will really like if all other software remain as it is. So like, as for an example, let's say you have installed Photoshop, you have installed maybe media players, you have installed photo editing, video editing, multimedia authoring tools, and office applications. Likewise, you have installed set of tools. Don't you like that after updating also all the tools are available to you without reinstalling? Yeah. So that is better, right? So thinking this idea, actually considering this, most of the vendors are trying to isolate the data portion from the software portion or the instruction portion, right? Otherwise, there are some dependencies. But this is not 100% true for all the cases, right? Because sometimes you keep the data with the software and you have a kind of a backup plan, or maybe a disaster recovery plan, or some other plan to handle that, right? So that can be there. Right. Okay. So let's learn about RDBMS, relational databases then. So keep it in your mind. So this part I have not included to the note, but so basically software and the data related to the software. So one method is you can keep all these things, data, software, instruction, everything together. That is one method of creating a software. The second method is you can make them independent. You can keep them independently, the data in one location, software or instructions in one location. That is then easy to handle, easy to backup, easy to upgrade, and your data will be independent regardless of the software corruption. Whatever happened to your software, still your data is preserved. So mostly, so think about that. If you uninstall Word, will all the Word files deleted or will it be kept in your computer?
Will be kept.
Yes, it will be there in your computer, right? If you uninstall Word, your files will be there in your computer. It will not uninstall the files. Later, if you install Word again, you can open them back, right? That means that data storage mechanism is independent from the software. Only thing is you will not be able to open that after uninstalling, but still you can open it back again once you install. Okay, so the database concept. So there are two, or actually there are more databases, but here we are going to learn about RDBMS or Relational Database Management Systems. Please write the heading RDBMS or Relational Database Management Systems. And kindly write down these facts. Actually, I'll be giving this note to you, but the thing is, so these concepts need to be kept. So these concepts actually need to be remembered. These are the main things. That's why I'm highlighting these points. Please write down this quickly. RDBMS, then these are the concepts. I'll explain that, right? Right. The initial concept, relational database. So what is a database? That is the centralized or the specific location where you store all the relations of the tables. Table, you know, this is a table. So example, this table is basically storing your name, gender, city, and the telephone number. This table has, these are field names. This side we call fields. Vertically, you have fields. And the field headings are called field names. Name is a field name. Gender is a field name. City is a field name. TP is a field name. So under that, you are storing the relevant values. Under the TP, you are storing telephone numbers only. Under the city, you are storing cities only. Under the gender, you are storing female, related genders only. Under the name, you are storing the names only. So the specific category of data type, specific data type is stored here in the vertical way into the fields. So these are called fields in the table. So collection of fields, basically collection of field values. So this is a collection of field value. It has a name, gender, city, and TP. It's a collection of fields values, but relative. This collection of relative field values we call a record. Right? Collection of related field values we call records. Can you tell me how many records are there in this table? How many record values are there in this table?
There's 3.
Yeah, there are 3 record values. So record of Dasun, record of Sidmi, and record of Sachini. 3 record values are there. How many fields are there in this group, in this relation of the table? How many fields? How many fields are there in this table? Yes. How many? Hello, I think you are muted. Minaga, am I audible? Hello.
Oh, sorry. Okay. Is that better?
How many fields are there in this table? How many records are there in this table? 3. Yes, that is correct.
Yeah.
How many fields?
So
Fields are this side, right? There are 1, 2, 3, 4 fields, right?
Yeah.
Okay, 4 fields. 4 fields and 3 records. Okay. Okay, then relational table is actually composite. It's composed with relation, or the table is set of records organized well, set of related records organized well. These are called relation. Then fields are the related specific data groups. Those are fields. And so here I have given that. Database is a collection of tables, but this collection of tables, these are interlinked, right? These are linked to each other. Here you can see this is a picture, snapshot of a database, a conceptual snapshot, not a real one, a conceptual snapshot. So you can see student is actually taking subjects. Student has subjects. The students studying subjects, and the students having teachers doing that subjects. So the subject and teacher is also related. And the students will get marks for the subjects. So there should be a relationship between the marks and the subject, right? Like this. And then student has attendance. You need to keep that. And teacher is assigned to the classes. And not just that, the students are also assigned to classes. There should be a relationship between the student and classes too. Okay, this way, the tables can be connected. These connected tables are called connected tables, or connected relations are called a relational database. Okay, got the idea? Hello?
Let me see. I'm just looking over my notes. Relational database.
No, relation or the table is a table. So relation is another term for tables. Table is collection of interrelated records. Are you clear on this? This is a table.
Yes.
This you have already. Okay, these kind of tables together create in a database.
Yes.
Okay. Inside the database, there are relationships. That's why these are called relations. What are the relationships? Teacher has students. Teacher is assigned to classes. Student has attendance. Student will get marks for the subjects. Student study subjects. Subjects are taught by teachers. So can you understand? There are relationships between these tables.
Yeah.
That is why this is called relational database. Are you on this?
Yeah, I understand.
Okay. Then field is actually the specific data group in a relation. So this is a field. TP is a field. City is a field. Gender is a field. Name is a field. Right? So field is actually related and relevant data items as a column. We call field. Data is a single fact about something, someone, or some concept. So then record is actually related field values. Together we call that a record. A set of related record we call a table, and set of related tables we call a relational database. The smallest unit is data. Data forms fields. Field forms records. Record forms table. Tables form database. Okay, from bottom to top. Understood?
Yes.
So if there are any difficult thing, please let me know, right? Because this concept is new to you. I think you have not learned about database previously, right? Have you?
No.
Okay. Since the concept is new to you, so if it is too fast, please let me know. Then I can slow down and explain thoroughly. Are you clear on these concepts now? Basic concepts?
Yeah,
Right.
the basic concept.
Okay. So now let's try to understand the language. So there is a language that we can, this is actually a fourth generation language. So more human friendly language. It's a fourth generation language, which is called SQL, structured query language, which can help you define the data definition. So defining the data, and which can help you define tables, structures, databases, drop in, delete in tables, delete in databases, maybe altering or changing the structure, whatever the structural change, structural changes are coming under DDL language, data definition language in SQL. SQL has few parts. SQL has few language parts, the data definition, whatever the structural changes. That means if you do change to these things, or the table, databases, field names, structures, that is coming under DDL. But whatever inside the data, okay, think like this. There is a bus or there is a car. If you do any modification to car, that is coming under the DDL. That is structural modification. If you are adding fog light, if you are removing fog light, if you are adding maybe visors, whatever the things, that is maybe new seat covers, carpeting, these are coming under DDL. Not about the car, I'm just telling related to a practical example. So if you are doing any modification to the car, coming under the structural change, DDL. But if you are modifying data, that means the passengers, or not passengers actually, if you are changing the driver, if you are changing the people moving on the car, so that is a data change. If you're changing the internal people without changing the structure, that means if you're changing internal data without changing the structure, that is coming under DML, data manipulation language. And the other hand, so that is actually deleting data, updating data, inserting data, only data changes. You are not doing any structural changes. Whoever inside the car, whoever come into the car, whoever drop in, whoever change, like swap in, whatever the things. So those things will be considered. That is only change of data, nothing happened to the car. DCL means who can do the things, who can drive the car, who can operate the windows. Is there a child lock? So then children cannot do anything when child lock is, when the window locks, shutter locks, all things, maybe who can put the signals, right? These are the controlling, who can do what, that is coming under the data control, DCL. And then transaction control, that means simultaneous occurrences, simultaneous processes. At the same time, there can be many processes running. Think about your bank account. If somebody, if you have a supplementary card to your bank account, do you know what is supplementary card? Or like, so there are bank accounts having supplementary cards. That means two cards are issued. So maybe one is used by the wife and the other one is used by husband, maybe something like that. So, but these are related to the same bank account. Do you know about such things?
No.
No, right. Okay, then things like this, like, okay. So anyway, you know ATM card, right?
Yeah.
Right. Okay. You know, the same time you can withdraw money from the bank directly without using the ATM card.
Yeah.
Okay. So if you know that, let's say you have $1,000 bank balance, and let's say your mom is going to withdraw $100 from this bank account, and you are going to, maybe your father is going to withdraw, your mother is going to withdraw from the direct bank account, and your father is trying to withdraw from the ATM card, same time, another $100. So let's say he's going to withdraw $950. So should be approved or not, these transactions? So what do you think? Your father is trying to withdraw $950. Same time, your mother's trying to withdraw $100.
No.
Should it be approved by the bank?
No.
So then what should happen? Because these are concurrent transactions, right? These are kind of simultaneous transactions. So the one transaction should be locked before the other transaction, right? So otherwise, what will happen? So both together will withdraw $1,050 from the account, because so when they check the balance, mother can see $1,000. So she's thinking, right, I can withdraw $100. When your father is taking the balance, he can see $1,000. So he will assume, yes, I can also withdraw the money because bank balance is enough. Both, I think, let's say both have not communicated to each other also. Both are trying to withdraw the same time. Bank refuses, saying not enough balance. Right? That should happen actually. Why? The one transaction need to be locked until the other transaction completed. Otherwise, what will happen? Otherwise, both can withdraw. Both can see the balance, means both can withdraw at the same time. The bank will ultimately be bankrupted. Right? So understood this scenario. These are called concurrent transactions, or the simultaneous transactions. If both party or if many parties are trying to access a single point, single account, or single instant of data and trying to modify that data, so there should be control. So that is done by the transaction control language, TCL. Actually, these are a bit advanced. We will not be learning DCL, TCL here, but we will be learning these two. These are some basics. We will be learning about DML and DTL. Right? That is what we are going to learn in this chapter under databases, under SQL. Okay, so I need you to write down this part as well. Sorry, because today, like, these are the basics. We cannot skip this, right? So please write down this quickly. Then I'll tell you how to install MySQL in your computer. Have you installed it in your computer or not yet?
Installed what?
MySQL. Have you installed?
No.
No, right. Okay. Doesn't matter. Let's try. First of all, please complete writing this. Right. Now this page, let's try to install this bundle into your computer. So actually, you can install this software, actually the database management system, independently. But there are another methods of installing. There is a software bundle too. This bundle is called, let me show. There's a bundle called XAMPP, XAMPP. So when you install that, you will be getting not just the MySQL or MariaDB, you are getting the other platforms such as the server-side scripting language, web server, and all these things together. But for the moment, we don't need all these things. So let's install MySQL DBMS database management system. So we can just download and install this to Linux or Windows or Mac OS. This is a cross-platform and it is free and open source. So then you can just install it in any operating system because it supports Linux, Solaris, Mac OS, Windows, FreeBSD. So 27 years ago it's released, but still used, and still this is used in the industry. So it's a very good interface, like it's very good solid database management system which we can use. But there are many, so like Oracle, PostgreSQL, MS SQL, but all are using similar SQL syntaxes with small minor changes. So let's learn in one, we'll give you exposed to the other DBMSs. So once you know how to write MySQL, you will easily know how to write Oracle, how to write MS SQL, PostgreSQL. All these things will be much similar to this. So first of all, let's go to the downloads and download and install this to your computer. Okay, so please refer that there are different MySQL, not enterprise edition, you don't need that. So you need like MySQL Community Edition. Community Edition means that is the free version, right? You need the Community Edition. So please download that and install in your computer. So you can search either, if you cannot find from this place, you can say MySQL like MySQL Community Edition. Community Edition for you are using Linux, I guess, Ubuntu, right? Then you can say, see this link, and there is a guide also. So try to self-follow that, or you can just, so this is for the Mac OS because I'm using that, it will be prompted to me, but you can just select your operating system, which is Ubuntu Linux, and then you will be getting this Debian bundles, actually a tarball or the Debian bundle. So you can just get the Debian bundle and get installed using your package manager, or you can type, right? Or you can type the command line command. So I think that will be much easier for you. Sudo to actually indicate that you are running with this administrative privileges. I think you know sudo command in Linux. So giving the administrative privilege and apt update, then so you can update the apt package installer package, and then you can say sudo apt install MySQL server, and after that you can start the service. That is, I think, very easy 3-command convenient way to install MySQL. Let's try with the command line. So otherwise you can use the graphical user interface and download the package manager and get it installed as a GUI tool too. So whatever you prefer. So I really like if you can do this command line. Okay, can you share the screen? Then I'll guide you in case if you're having errors.
Okay. So I just like,
yeah, you can try the commands. So first of all, you have to update the package manager.
oh, I already did.
Oh, yeah, already. Okay, yes, you have to put by, yeah. Then it's downloading. Let it be. It will take some time, not a big time, but considerable amount of time, like 5 minutes maximum. Yes, it's running as the PID. So few to go. This is starting the service. Created the sim link is created there. Okay, now you can start the service. Okay, press enter. And yeah, I think it has started already, right? So it is a command line interface, right? Then the next thing is like, how do we log into MySQL? You can type sudo space MySQL. Press enter, and yeah, now you are in MySQL prompt. Simple, right? You can type few commands to verify whether you are accessing the DBMS. You can type show databases, show space databases. So please write down these commands. Later you will need a basis, a semicolon to end the statement. Semicolon to end the statement. There is colon, right? No, there is quotation. The last line should be just using arrows, semicolon. Yeah, press enter. You can see there are 4 databases currently available in your database management system. 4 databases, right? They're showing it. And so I'll give you a few commands just to get some exposed to this. I'll systematically teach this next day, but just to allow you practicing, we have 1 week of time to start the next class. So you can just practice. You can use create database command to create a new database. If you want that, you can use create space, create space, then a database, then any preferred name for your database. If you want to see that again, how to check? Show data, yeah, same command. You can recall the same command, show databases. Can you see your new database, new DB is now available? Yeah, that's it. So this is using the, like, we can install PHP MyAdmin, that is a GUI tool. When you install PHP MyAdmin, it's a GUI tool which is supporting, no, often will not often that. You have to use command. Use new DB. So that is the command. Use new DB, right? Your database name. Yeah, and then you can see database changed. Right now you are in the new DB database. Then occasionally try to create a table, but this has like some more syntaxes. So let me show it to you first. Now, if you type show databases, you won't be able to see that. So you will be see the database. But if you want to show the tables, you can write show tables.
Oh,
see the tables, show tables. Use new DB, okay, then show tables, and it will display. So see how these are called 4th generation languages, right? It's like English. It's like empty set means you don't have any table yet, right? It's like English, so structured English. That is why. So these are called 4th generation language. It's very convenient, easy. The syntaxes are very, very easy. It's like English. Okay, let's see how to create a table. Okay, so I have to install that. I'm not sure that I have installed it. Start MySQL. SU. No, so I'm not sure about the commands because I have not used this for a long time. Mac OS start. Now MySQL server starts. MySQL server start. Okay, I'm done. Oh. There's something wrong here in my installation. I'll try it next time. So, but using your computer, I can show you. So can you share the screen back again, please? Minaga, please share your screen. Hello. Yeah. Okay, start the terminal back and let's create a table. You can use create table command, create table, then the table name. But here you have to define the field names. That is the challenge, right? Create table, table name. Let's say TBL student or student, student. STUDENT, student. Then open the brackets, student. Open the brackets. Don't close it. Oh, don't close it. Create table student. You have to rewrite the command. Don't be hurry because this has a definition. Open the bracket. Don't close it. Don't close it. Press enter. Press enter. Now you have to define the field names. So let's say you are going to start the student name, city, and the telephone number. Then you have to define them. Okay, first thing is, let's say ST name without spaces, ST name. ST name, yeah, student name. Like this is like a variable, right? Variable in Python. So space, you have to tell, after space, you have to tell the data type. So student name can be number of characters, but we don't know the exact number of characters. Therefore, you can say varchar. Varchar, VARCHAR. VARCHAR, varchar. Within bracket, char, varchar, VACHAR. R should be there. The letter R. No. Before the brackets. CHAR. Then open the bracket. Okay. Then you can say the upper limit. Let's say 30 characters. 30. Close the bracket. Okay. I'll give you the more definitions next day. For the moment, let's create a normal table. So since the student name should not be empty, you can keep a space and say not null. Space, not, N-O-T, null, N-U-N-L. Null means empty. And so this is the main identifier. You can assign that a primary key to. So I'll explain this concept. Don't be confused. Put a space and write primary key. Comma. Comma, go to the next line. Press enter, go to the next line. This is the definition of the student name. Then let's say city. So let's say city varchar 30, varchar 25. City, right? City ST, is it okay to put ST or city CITY? What do you think? You can put ST, that doesn't matter, but use a meaningful one. So you just use varchar 25. Put a comma. That is student city, right? Put a comma to finish that definition. Press enter. TP, telephone number. You can say space. If you know the number of characters, you can put exactly. But if you don't know the number of letters or number of numbers, number of digits, you can put upper value. Or if you exactly know, you can put char and put the exact. So how many digits are there in a telephone number USA? Is it 12?
10.
12 or 10?
10.
Right. Okay, then you can say char 10. CHAR, not varchar. You can say CHAR. Exactly, you know. Char, then 10. Okay, now close the other bracket that you have previously opened in the first line. Now semicolon. So this is the definition of a table. Press enter. Yes, query okay, 0 rows affected means you have run that perfectly, and now you have the table. You can show the tables in the database. Show tables in the tables. Yes, should be there. Okay, now you can see the student table. If you want to describe that, you can use desk, DESC, desk, then the table name, desk space student. That will describe the student table. Enter, and you can see student name is varchar 30, and it is not null, it's a primary key. and no extra things. And ST is like I think the city that you have use ST. If you want, you can change it. Yeah, doesn't matter. You can later change it. This is actually DDL. What we have learned today, what we have practiced today is DDL, data definition language, DDL commands. These are some DDL commands. So shall we create another table alone, maybe teacher table with few fields, teacher name, teacher city and the teacher's, teacher name, teacher's telephone number and teacher's subject. So shall we create that table alone? Teacher has three things. Let's say teacher. I'll show you the device. I'll send it to the chat. So teacher table has few fields. Let's say teacher has a teacher name and subject that she or he, and the gender, and also teacher name, subject, gender, and let's say TP number. So can you create this table? I have sent it to the chat. But you have to, like the data types and all, you have to define. So let's say your teacher name is the primary key, the main identifier. And then, okay, let's store gender with one character, MOF. Gender with character one, only one character, MOF. So let's see something like this. Yeah, other things you can. Shall we create a table? No, yeah. Create table teacher, okay. ST name is student name, here teacher name.
Oh.
T name or something, or name. No, don't type the values. We can't type value because this is only for data definition. DD, that is creating the table only. Don't type the names, values, etc. there. So what you need to do, if the first line is correct, T name, don't give a name. Hello?
Hello?
Am I audible? Don't give Mr. Disana or something there. So that will not be entered to your table. T name is just give the data type only. You can say vacha, T name space vacha, space variable character, vacha. Then the number of characters, let's say you are entering 30 characters, 40 characters, you can say. Then space not null and the primary key. Comma, the next line. Yeah, there you can type subject. So let's give the value maybe vacha 15. You can define, you can decide what is the value, etc. Comma. The next is gender, cha1, because we are going to type only one character to identify the gender MOF. Gender cha1, comma. The next is TP number. So let's put it cha10.
Oh, I didn't put a comma for that.
No, you can put it late. No need to comma, put a comma because this is last line. You can finish with the bracket.
Okay. So
and the semicolon. Just to put the bracket and the semicolon. Closing bracket and the semicolon.
Oh, this is it? Okay.
Gender, after that you need semicolon, right? Sorry. So then, yes, erase that, put a comma there. Erase that, put a comma.
Oh,
just comma.
How do you erase it? Okay.
Just comma there.
Here?
Then write down the other one, which is TP number, TP num space chart n. Yeah, you can write like that. Chart 10, then the bracket close and the semicolon. Close bracket and the semicolon. Okay, enter. Right, done. So this is because you have to be careful. You are using CLI, right? Command line interface. Because if it is GUI, you can edit the previous commands, but since it is CLI, you will not be able to edit them. So you can describe it, desk teacher, and it will be described in the table. Desk, DESC, teacher tables. Desk teacher, TEACHER, desk teacher will be described in the table back again. Yeah. Okay, then you can see the values there. Okay, so teacher name, watch, okay, done. So this is how you are creating a table. Right. So since time is up, so we need to insert data, DML commands, we need to learn them. So there are more to learn. So considering the time, I'll be putting that to the next day. For the moment, just go through and practice these things. So please write down these things also, because I have not given any note. So please scroll up, write down these things. These are important facts. Then next day I'll be doing the DML part.
Okay.
Goodbye.
Bye.